All right, I wanted to do some more examples for you that involve the law of sines and the law of cosines. So let's look at this first example where we're going to solve all these problems we're going to do. We're going to be solving the triangle. That's going to be the big idea here. All right, so let's see what we have. Let's just draw a triangle to start with. I'm not worried about scale at all to start with this. All right. So let's say that my A, B, C is here. So this is little a, this is little b, this is little c. All right, so this one is 15. This one is 40 degrees, and this one is 88 degrees. And we're asked to solve the triangle. So when we're solving the triangle involves finding all the lengths of the sides and all the measures of the angles. That's what we mean by solving the triangle. All right, so we already know that the measure of A is 40 degrees and the measure of B is 88 degrees. And we know that the length of A is 15. So we need to figure out these three values. Well, one of them we get for free. That's the angle at C, because we know that the angles of the triangle add up to 180 degrees. So we know that the measure of angle C will be 180 minus 40, which is 140, minus 88, which gives us what, 52? So measure of angle C is 52 degrees. All right, so it's B and C that require us to do a little bit more work. Now, notice that if we were trying to find an angle, if we're trying to find a side for using the law of cosines, if we want to find a side, I have to know what the other two sides are, right? Because remember, your law of cosines has your c squared equals a squared plus b squared minus 2ab cosine of c, right? Now, in order to find, and we can always rotate around the a, the b, and the c as well. We talked about that earlier. But in order to be able to use the law of cosines to figure out a side, which is all I have left are sides, I need to know two of the sides, and I only know one. So the law of cosines is not going to help us here to start with. Okay, so instead, I have a side, and I have its opposite angle, and I have another angle, so I can figure out its opposite side to start with. So I know that the sine of 40 degrees over 15, sine of A over A, is sine of 88 degrees over B. So I can solve for B. And if I solve for B, we get, what, 15 sine of 88 over sine of 40. A little bit of algebra there. I'll let you check that. Okay. And if we go over to our calculator, so go over to the calculator really quick. We had 15. Oops, let me do one thing real quick. I need to change this over to degree mode. So 15 sine of 88 degrees divided by sine of 40 degrees. And we get about 23.3216. So let's go back over. 23.3216. Now that I have the second side, I could use, theoretically, the law of cosines to find the third side. But it's better to use non-rounded values if I can, whenever I can, to figure out other values. And if I try to use the law of cosines here to figure out my C, I'm going to have to use a non-rounded value or make sure I keep all my digits in my calculator. So I think this one's a little bit easier to use the law of sines again. Just this time using angle C. It's also not as many computations if we can do law of sines. So we get 15 times the sine of 52 degrees divided by the sine of 40 degrees. And if I go back over to my calculator, I can go back and do second entry. I can get the old entry. The only thing that changed here was this 88 is now a 52. And we get 18.3889. So going back over here, 15.3889. All right, and remember again that, I'm just going to write these up down here so that I have these all in the same spot. Remember that the bigger an angle, the bigger the side should be opposite it. So in this case, the 15 should be the smallest side of the triangle because it's opposite the smallest angle. And the biggest side B here, the 23, should be opposite the 88, which we really do have here. So our numbers make sense in this context. All right, let's look at the second problem. Again, we want to solve the triangle. So A, B, C, measure angle A, measure angle B, measure angle C. A is 13, B, oops, sorry, not B. C is 14, measure of angle B is 75 degrees. So let's draw our picture. Again, I'm not worried about scale. So A is 13, C is 14, measure of angle B is 75 degrees, and we still need side B. All right, remember that if you're going to use the law of sines, you have to have a side and an angle opposite. Well, notice that each of our sides that we know do not have an angle opposite it. So I can't use law of sines to help me get anything here. So I'll use the law of cosines instead. So B is the angle, the side we're trying to find. So we'll have B squared is A squared plus C squared minus 2AC cosine of B. All right, A is 13, C is 14, and B is, I wrote that backwards, this is 13. And B is 75. So if we put that into our calculator, I want 13 squared plus 14 squared minus 2 times 13 times 14 times cosine of 75. We get 270.7898 and change, and remember that we're going to want to take that was what B squared is, so I'm going to want to take the square root of that. Oops, and I need to go to that because I want second answer. So this, sorry, I mistyped it again. Second answer, enter. So we get 16.4557-ish. So going back over here, going back over here. So B is approximately 16.4557. All right, so now that I have B, I can figure out one of our angles. I can use law of sines or law of cosines to get our angle. So B is the biggest side here, so it doesn't really matter. I don't have to worry too much about using the law of sines to get my angle. So let's use the law of sines here. So let's say that sine of A over 13 is the sine of 75 degrees over the 16.4557. So scroll up a little bit here. Sine of A is going to be 13 times the sine of 75 degrees divided by the 16.4557. We have to do the inverse sine of that. And let's go over to the calculator then. Over to the calculator. We have, what was it, 13 sine of 75 degrees divided by the B, which is second answer. And we get 0.7, oh, and I need to do the inverse sine of that. So inverse sine of that answer. And we get 49.7336 degrees. We found an angle here. So going back over, 49.7336 degrees. So starting to fill these in again. This was 16.4557. This is 49.7336. And now to figure out angle C, I can do is going to be 180 minus the 75 minus the 49.7336. And I might as well do that on my calculator. All right, so I already have the angle for A there. So I'm going to do 180 minus 75 minus the previous answer. And you get 55.2634. So 55.2634 degrees. So that's our last entry for that triangle. All right, let's do another one here. This one's a pretty straightforward one. This one's asking us to find the triangle, or solve the triangle. This one's a pretty straightforward one because if we're really, really good at what we're doing, we can see that this is going to be no triangle right away. Remember, for any triangle to exist, the sum of any two sides has to be greater than the third side. And we notice that if I take the 8 plus 7, that's 15, which is less than 16 the third side. So that tells us we have no triangle. Okay? Right away, we know we have no triangle. If you did not notice that to start with, you could still use the same principle that we talked about in class. Always, if you're going to use the law of cosines to find your first angle, always find the biggest angle first. Every time. Always find the biggest angle first. Biggest angle is across from 16, so we would have 16 squared equals 8 squared plus 7 squared minus 2 times 8 times 7 times cosine of b, because that's the side, 16 is side b. All right, so you would have 256 is equal to 64 plus 49 minus, this is 56 and 2, so that's 112. 64 and 49 together make 113. If you subtract the 113 to the other side, you get 143 equals negative 112 cosine of b. Cosine of b, it would be negative 143 over 112. That's bigger than, well, sorry, the other way around. It's less than negative 1. And remember, the cosine always has to be in between negative 1 and 1, and this isn't it. So this, again, would tell us no triangle. If you try to put this in your calculator and do the inverse cosine of this number, it'll give you an error. Okay. So either way, you're going to get no triangle on that one. All right, so this one we will get a triangle because we have the right principle of if we add any two sides together, it's bigger than the leftover side. So what I was just mentioned in the previous one, when you're solving for an angle using the law of cosines, find the biggest one first. Okay. 38 squared equals 34 squared plus 31 squared minus 2 times 34 times 31 times cosine of b. I'm going to save switching over to the calculator here at the end. I need to subtract the 34 squared and the 31 squared to the other side. And then divide. So I would have cosine of b is 38 squared minus 34 squared minus 31 squared divided by 2 times 34 times 31. And I need to do the inverse cosine of that. And now I'll go over and get my calculator. All right, what did we have? We had inverse cosine, parentheses on top, 38 squared minus 31 squared minus 34 squared, end parentheses, divided by, put new parentheses in, negative 2 times 31 times 34. And we get 71.3818 degrees. Okay. So this was 78.3. 3818. Sorry, I just forgot what the number was. All right, so that's one angle, and this one's going to be the biggest angle because it was across from the biggest side. So we still need to find the other two angles. So we can use law of cosines or law of sines for whichever one you want to use. It doesn't matter which. But I'll use law of sines. It's a little, like I said, a little easier to type in. Sine of A over 34 is sine of 78.3818 over 38. So if we multiply by 34 and take the inverse sine, you get A is equal to the inverse sine of 34 sine of 78.3818 over 38, which is approximately, if we go back to the calculator now, this was the angle that we had. So we had 31, was it? 34. All right, so I need to do, see if I can get this on the same screen at the same time, and that'll save me a little bit of time here. So we need to do inverse sine 34 times sine of the previous answer divided by 38. And that gives us over here 57.9854 degrees. All right, so that one's one of our angles. The 71.3818 is another one of our angles. So now I can do 180 minus the previous answer and then minus the 71.3818, and that'll give us angle C. So just to write that down, measure of angle C is going to be 180 degrees minus the 78.3818 minus the 57.9854, which gives us 50.6328. Okay. So just to recap this problem, we found the largest angle first, which is the one that's opposite the largest side. The reason we use the law of cosines is because I had no angles to start with. To be able to use the law of sines, you have to have at least one of the angles to start with. So we used law of cosines to start first, solved for one of the angles, and then I switched over to the law of sines to figure out the other angle because, again, the formula is a little bit easier. It's the only reason why I switched. You could have used the law of cosines again to find another angle if you wanted to. Then to find the third angle, we just needed to subtract the two angles that we found from 180. Let's do another one. All right, so this one, draw the picture again. A7, B16, measure of angle A is 30. I don't know B, or excuse me, I don't know C. All right. So, notice that I have a side and the angle opposite it. So I can use law of sines here to help me out. So I'd have sine of 30 degrees over 7 is equal to the sine of B over 16. So sine of B has to be 16 sine of 30 degrees over 7. Well, remember that's 30 degrees. That one's one we actually don't. I don't even need my calculator for that one. Sine of 30 degrees is 1/2. 1/2 times 16 is 8. So I get 8 over 7. That's bigger than 1. So I cannot do the inverse sine, because remember the sine of any angle is always between -1 and 1. So this one has no triangle. Okay. All right, similar setup but this one. All right. Same setup except for the fact that we have the 10 over there for A. So sine of 30 degrees over 10 equals sine of b over 16. Sine of b will be 16 times sine of 30 again is 8 over 10. So b will be the inverse sine of 4/5, if I simplify that. Let's grab our calculator here. Inverse sine of 4/5 is 53.1301 degrees. All right, now, one of the quirky things about inverse sine is it gives you an angle in quadrant 1 that has that value for sine. So this 53 and change is the angle in quadrant 1 that has a sine value of 4/5, but there's also one over in quadrant 2. It's also possible that angle B, let's measure of angle B, could be 180 minus 53.1301. So, doing this on the calculator, this is approximately 126.8698. And if we add that 30 for measure of angle A, I get something that's less than 180 degrees. So I get a second triangle. So this is the check that we have to do. We have to check whether or not this number, when we did the supplement of the angle we found using the law of sines, subtracted it from 180, because remember this is the quadrant 2 angle that has a sine equal to 4/5. I add it to the other angle that we have. If it's less than 180, we get a second triangle. So in this case, we have 2 triangles. All right. So let's see if we can figure out what those are. So I'm going to use this angle for one of my angle B, and I'm going to use this angle for my angle B. So this is going to be how we're going to find the second triangle. So triangle 1, we have measure of angle A is 30 degrees. Measure of angle B is 53.1301 degrees. So I can figure out measure of angle C by subtracting these two values from 180. So you get what, 126 point, not 126, sorry. I can't subtract. This is 83 from 180 is 96.8799. That should give me 150 when I add those together. I know that side A is 10 and side B is 16. I still need to figure out side C. I'll do sine of 30 over 10 is sine of the 96.8799 over C. Again, sine of 30 is a half. So you'll get 20 sine of 96.8799, which is approximately, okay, so I need to do, let's do the inverse sine of the 4/5 again, so I have that angle in there. I need to add 30, and I need to subtract it from 180. All right, so I need to take the sine of that and multiply it by 20. So 20 times sine of second answer. So our C in this case is about 19.8564. So this is your C that would go up here for triangle 1. I still need to do triangle 2. I'm going to write it at the top just because I'm out of room. Triangle 2, measure of angle A, still 30. Measure of angle B, though, was 126.8698 degrees. If I subtract those from 180 again, we'll get, what, 23.1302. A is still 10. B is still 16. We need C, but we can do C in the exact same way that we just did it before. Move some of this stuff out of the way here. Sine of 30 over 10 is sine of 23.1302 over C. Again, sine of 30 is a half, so that makes this 1/20th. So if I multiply to the other side, I get 20 sine of 23.1302, which is approximately what? Well, let's see here. Let's, I need to get that 126.8698 again. So let's do inverse sine of 4/5. And we had to do 180 minus that. That was our 126.8698. I need to get that 23.1302. I add 30 and subtract it from 180. That gives us 23.1301. All right, so I must have rounded in a bad spot. So this should be a 9 here, it looks like. This is a 1. That's okay. It's not going to throw us off too much. I need 20 times the sine of that. And that our C is going to be then 7.8564. Sorry about that. 4. That's what's going to go up for C. All right. So that gives you an example of doing two triangles. Let's see if we can do a couple of examples here now of application problems. We have a national park. You've got something at the southwest corner, something at the southeast corner. These are 10 kilometers apart. There is a distress call somewhere out in the park. The Southwest Ranger says that the camper is located with a bearing of 61 degrees from the southern boundary. From the southeast one, it says it's 9.2 kilometers to the camper. And the first one says which station is closer and what is the difference in the distance. All right, well, notice that I have an angle and a side opposite. I want to know what this side is over here. I want to know what this side is over here. I need another angle to be opposite that side, which I don't have yet. I can figure out this angle using this side, and then I could have this angle and figure out that. So let's say that this is A here, this is B, and this is C. I know that sine of A, not sine of A, sine of C over 9.2, C is 61, by the way, is sine of B over 10. So I get B will be the inverse sine of 10 times the sine of 61 over 9.2. I know I did two steps at once, but all I did was multiplied by 10, that's where this 10 is coming from, and then did the inverse sine of both sides to get rid of the sine. This will be approximately, well, let's get the calculator up, 10 times sine of 61 divided by 9.2, and then I need to do the inverse sine of that. And we get 71.929. All right, so that gives us this angle up here. So we need to figure out what this angle is here in order to figure out what A is. So to figure out the measure of angle A, we'll take 180 and subtract 61. And subtract 71.929. I think I forgot a digit, 9291. So I'm going to do 4 decimal places. So what does that give us? This gives us, what, 119. So this is approximately 1 147.0709. That's not right. Try that again. I subtracted from 180. 119 gives you 47 point that. Sorry, I don't know why I said 147. It's 47 point that. All right. My apologies again. All right, so now if we do the law of sines now to figure out what A is, I would have that sine of the 47.0709 over A will be, I'm going to use the 61 because that was one of the given ones for us. I don't have the rounding issues. So A will be 9.2 times the sine of the 47 divided by the sine of 61. So let's go back and grab the calculator. Here's the expression. I need the, let's see, this is my A. My B was 61. I take the 180 and subtract it. There's the 47.0709. I need the sine of that times 9.2. So 9.2 times sine of the previous answer, and then divide by the sine of 61 degrees. And I get approximately 7.7019. So the ranger at the southwest station is closer than the ranger at the southeast station. And you could subtract the two to figure out how far apart or which one's closer. Well, how much closer is it? All right. I'm not going to bother doing subtraction. Okay, so let's do this last one here. A plane flies 500 miles on a straight path and then turns left 12 degrees on a new heading and goes another 300 miles. So when it says turns left 12 degrees, that means this angle is 12 degrees and keeps going 300 miles. And wants to know how far is it from its original location. Well, since I know this is 12 degrees, this has to be 168 degrees because this forms a straight line. I've got two sides and its included angle. So that tells me the law of cosines. So c squared is 500 squared plus 300 squared minus 2 times 500 times 300 times the cosine of 168 degrees. And now we can type all of this in our calculator. So let me just shrink that in there so you can actually see it on the screen at the same time. So we would have 500 squared plus 300 squared minus 2 times 500 times 300 times the cosine of 168, not 1168. So that, remember, that's c squared now, not c. 63,3444.28. So I need to do the square root of the previous answer and get c is approximately 795.8921 miles. All right, so I know I went through some of these a little bit quickly. What I would suggest looking at is just try see if you can do the problem yourself and then go back through the explanation to see if those things make sense. So anyway, that's some more law of sines examples. We've got the worksheets on Moodle as well, and for what we've talked about in class. So, and anyway, I'll talk to you later.